Hello everyone, welcome back to my math channel online today again. In this video today, I will share with you another my PowerPoint presentation. And the topic I would like to talk about today is about the function and their operation. So I am sitting here in my living room. You probably noticed I changed a little bit the background refresh because today is such a beautiful day and I would like to sit in my living room and looking through the beautiful window with all the pine trees and the magnificent mountains around, and I feel very blessed. Anyway, I would like to share with you about the next unit we will learn in the course Pre-Calculus Math 12, which is function and their operation. So far, we have learned the first unit about function and transformation. The second unit, we learn about the radical function and polynomial function and rational function. So before I move on to the next unit, which is logarithmic function, I would like to talk a little bit about the function and their operation. This topic can be more complex, and therefore in my presentation, PowerPoint presentation now, I only can share with you some of the main ideas before we get into the actual lesson on the board, because there's only the instruction on the board can make you understand the operation of the function. Anyway, let me share with you my PowerPoint presentation today in this topic. And again, if I make any technical mistake, please forgive me. But I hope that I will not make mistake, because as I get going, each day may be better. So let me share with you about my PowerPoint presentation today. So you can see that from the screen here, we have the slide function and the operation. So let me present it online so you can see it. So here I'm talking about the function and their operation. So identify function in one-to-one function. So that is the first thing I am talking about that. So let's go to the next unit. So here in this slide, I asked the question, which of the following maps is the function? So we have two maps going on here, the first one and the second one here. So how do we know which one is a function and which one not? Now recall that in our real life, we always have a relation. However, not any relation are the function. Most of the relation are the function, but not all of them. And if it is a function, then it's for sure it have a relation. So let's look at the first slide here. I'm talking about the first one here. how do we know this one is a function or not? Now, when we're talking about a function, we're talking about the input and the output. So it's like a vendor machine. You input some coin and you expect the machine will perform the function to give you an output, whether it's a Coke or it is a Pepsi or it is a bag of chips. So anything we input, we call a domain, and output is a range. So in this map, there's one button here, is the red button here. So this red button is the one input, but it gives two different output. So if you put in the vending machine, let's say $2 coins, and then you press the button and you get the Coke, which is cost $2, and then you get another bag of chips, which it costs you $5. Then you know that this machine doesn't function very well, because one input, the same input to give different output. So in math, this is a broken function, and this is not function very well. And therefore, this relation here between the red button here and the two blue button here is just the relation between them, between the input and the output, but this is not a function. So based on this map, we will not allow any of X domain here to give different range here. Whether it give different range or give the same range, as long as it came from the same input, we not allow it. So let's go to the next, let's look at the next map here. So the next map here, we're talking about, in this map, you can see that -1 give you a number 1. But then you have a +1 also give you a number 1. Is this acceptable or not acceptable? Yes, it's acceptable, because even though you get the same output of number 1 here, but this output came from different input. So therefore, it's acceptable. It's just similar to if you can input the $5 into the machine and you expect to get the bag of chips, or you can input another $2 and you expect to get the same bag of chips if the bag of chips is less than $2. So it doesn't matter, you can input different dollar, you can input $2 or $5, you still can get the bag of chips. So that's the idea. And you can see that the 7 input give you a 49 output. The 5 input give you a 25 output. So this is the perfect function. There's nothing wrong with it. So which of the following map is a function? The second one here is a function. So now let me go to the next slide. So the next slide say identify a function and an one-to-one function. To identify a function, we can use a vertical line test. If the relation is a function, then the vertical line test shows not any same X values give the same or different Y value. To identify a one-to-one function, we can use a horizontal line test if it is a one-to-one function. Then the horizontal line test shows not any same Y values give different X value. So let's take a look at which function here is which of the following graphs is the function. So let's look at the first function here. You can see that this is the function, and the dotted line here is just represent the vertical line test. So the vertical line test here show us that this vertical line test intersect this function at x equal maybe here 1, 2, 3. So at x equal 3, so if x equal 3, what y equal? Y equals 0. And there's only one x associated with one y. One x of 3 associated with one y of 0. So therefore, absolutely, based on the vertical line test, we can see this is the function. Now let's look at the y-axis here as the vertical line test. You can see this function cut this function intersect the y-axis at one point of y value. At that y value, at this y value, the x here is 0. So if the input is 0, the output here is maybe 2 at y equal 2. And there's only one input associated with one output. And if you draw many vertical line tests, at any point, the function only intersect the vertical line test at one coordinate, one pair of coordinate of x. So at any point, this vertical line test only demonstrate that there's only one x associated with one y coordinate on the function. And therefore, we know this is the function. Doesn't matter, we can draw many vertical line tests or one vertical line test in here. Now, let's take a look at the next graph. Why this one is say not a function? Based on this vertical line test, you can see that the vertical line test intersect the graph here at one point right here. At this point, the x coordinate the same for the first y here and the second y down here. So this vertical line test intersect this graph at y1 on the top right here and y2 at the bottom right here. With the same x coordinate domain here, the same x value here, give different y value. Y1 on the top here intersect the graph at this point, and y2 intersect the graph at the second point at the negative y. So therefore, we know this is not a function. And the next image, you can see exactly the same. This vertical line test intersect this function, this circle, at the same x, but give different y. The first y in here and the second y down here. So therefore, this is not the function. So let's take a look at what the next one. So here we're talking about which of the following graph is a one-to-one function. And you can see that the vertical line test to show us whether or not the function is a function, the relation is a function or not. But the horizontal line test like this will tell us, will let us know that is this relation not only a function, but also a one-to-one function or not. Now, for sure, before it is a one-to-one function, it must be a function first. So this is the function for sure, but it's not a one-to-one function. And the reason because if you take a look at this horizontal line test, you see that this parabola intersect the horizontal line test at 2 points here. So at these 2 points, they have the same y value, which is 2.5 right here, 2.5. But the same y value have a different value of x, different value of x. So this y here, 2.5 here, on the left of parabola have an x as minus 1.5. This 1.5, sorry, 2.5 y here have an x as positive 1.5. As well as the second horizontal line test. Cut the graph at 2 points. At these 2 points, they have the same y value, which is 1.5, but they also have different x value. And based on this horizontal line test, we know this function is not a one-to-one function. And if the function is not one-to-one, we cannot find its inverse function. To have inverse function, we have to cut this graph and only operate either on the left or on the right. And then we can draw an inverse function for just one branch of this function. So this is not the one-to-one function. Now take a look at the second graph here. You can see that the first horizontal line test go through the function at the y value of 1.5 and the x value of 0. And there's only one y associated with one x, or one x associated with one y. So only one input to give one output. If we draw the second horizontal line test here, this horizontal line test go through this function at the at 2.5 and at 2.5 for y with the x of 2.5 with the x as 1. So this horizontal go through the y as 1.5 and x equal 1. At the second horizontal line test, is cut the function at the point 2.5, which is different y, and also different x, because this is bigger than 1 a little bit. The x here is bigger than the 1 a little bit. So you can see that, therefore, the second one here, the second graph here is a one-to-one function. And this one is not a one-to-one function. And again, in one-to-one function, we not allow for the same y, but give different x value. Here, we have a different y and give a different x value. Then none of them have the same y here. You can see the first horizontal line test cut the y at 1.5. The second cut the y at 2.5. And therefore, the second graph here is the one-to-one function. And we can find an inverse of this function. Okay, so let's get into the next slide and see what happened. So for the next slide, I'm talking about which of the following graph is one-to-one function. Now, obviously, if you draw the first graph here, you draw the vertical line, horizontal line test, then you can see that this horizontal line test will have the same y at 2, but give a different x. It give different x. So therefore, this is not a one-to-one function, and we cannot have an inverse of this function. Let's take a look at the linear function here. If you draw the horizontal line test, each horizontal line test only can cut the linear at one point on the graph, which is 1y associated with 1x. 1y associates with 1x. If you draw another one here, the y here is 2 and the x here is 2. If you draw another line here, the y here is 1, but the x here is 4. So therefore, this is a one-to-one function. For the circle, you know the answer will be not one-to-one function, because if you draw the vertical horizontal line test here, it will go to the y at 2, but associate with different x number, x value. So therefore, this is not the one-to-one function. So let's take a look at the next slide. Only a one-to-one function can have its inverse. So for example, if you look at the orange function here, look at the blue function here. The orange function here is the inverse of this blue function. And the inverse of this function goes through the mirror line. If you draw a mirror line here, y equal x, go through this x, go through this coordinate grid, then you will see the mirror line is the y equal x. Is this line in the middle here? Follow my my point, right? So this is the inverse function, and therefore this blue function has its inverse, and it is a one-to-one function. Now, if you look at this parabola here, the whole function orange here is not the one-to-one function. However, if we talk about the right branch here associated with the dark blue here, then this function, the right branch of this parabola is a one-to-one function, and therefore have an inverse function here. Now, if you talk about the left branch of this function, then only for the left branch here, this is the function, one-to-one function, and it has an inverse down here. So the whole function is not the one-to-one function, but if you cut it and you just look at the one branch at a time, then yes, it is a function and it has its inverse like that. Okay, so now let's go to the next slide. The next slide, I'm talking about state the domain and range of the function. So you have a domain of this graph. The domain is a set of x value. So if you look at this function along the x-axis here, now keep in mind that this function keep expanding on the top here and expanding to the left here, and it getting it keep going and expand both left and both right. It just expand in a very narrow behavior, but it keep going. So therefore, the domain of the x set of x value here is not limit between -2 and 2. Even though it goes through the point, it appears to us like between -2 and 2. But keep in mind that because this arrow keep expanding on top and expand on the left and expand on the right. So the domain for x here is x belong to on the real number, on way from negative infinity this way to positive infinity this way. Even though it's shown here only between -2 and 2, but keep in mind this is keep going, and therefore it keep expanding on top as well, expand to the right and expand to the left like this. Now, the range is the set of y of the function. So when we're talking about function, we look at their domain and their range, and the range is the set of y. Now, noticing that this function is cut short, it only appears from down below -2 a little bit. So maybe I estimate this in -2.3. So therefore the y of this function is anything, sorry. Y of this function is anything bigger than -2.3. So from -2.3 go up to positive infinity. And therefore we state the range of this function is we state the range of this function is y, a set of y such that this is the such that we interpret this line as a such that y will be bigger equal -2.3. So that is about the range of this function. So now let's go to the next slide and see what is our next slide. So our next slide, I'm talking about the state the domain and the range of the function. So state the domain and the range of a function. So here is a function, is another function. It's a weird function, but it is a function. So if you look at this function, the end point is right here because there are no arrow. If it arrow, it will indicate it keep going, but there's no arrow. There's a dot here. It says this is the ending point of this function. As well as this dot here, this is the ending point. So the domain is a set of x value along the x-axis contain this function. And the set of x value here such that the x belong to from -4, because the function ending at -4 it not keep going. So start from -4 to +3. That is the domain of this function. So from -4 to the +3. So -4 and 3. And the square brackets show that this is including the number, including the value of -4 and including the value of 3. So this is the domain of this function from -4 to +3, from -4 to +3, where the assistant of function, assist, belong to the domain of -4 to the 3. Now the range is a set of y of this function. So this function have a set of y all the way from -1 down here, start from -1 here, and on the way up to this value, 3. So the range is from between -1 and 3. So this is, we look at the range of the function. We see it start from here, from this point, -1, on the way up to 3. This is the range of this function. This function only exists between -1 and 3 for the range. So let's look at the next slide. In this next slide, I'm talking about the functions operation. So when we're talking about the function operation, we talk about addition and subtraction of function. So given you a function f of x and a g of x and another function h of x, then the operation of this function mean you can add the function f plus g plus h of the x. And this notation, it just show you how you can write the notation of the function. So example, fx equal 3x minus 1 and gx equal x plus 2. then the sum of f of g of x is equal to 3x minus 1, adding with x plus 2. And now you add the like term, 3x add with the x is 4x. Minus 1 add 2 become positive 1. So this is the result of the addition of these two functions, f of x and g of x. The same like you subtract, their differences is f minus g of x. And you get familiar with how to write the notation function, something like this. So 3x minus 1 minus the gx, you have to put in the bracket, because if you don't put in the bracket, it doesn't mean that you subtract the whole function. Maybe you just subtract the x or you just subtract the 2. And that's why you have to put them in the bracket. And so that you don't make mistake about their signs, positive and negative as well. So here you see that 3x minus, when you open the bracket, this minus x is still minus x. And minus 1 is this number here, and minus 2. So the answer for their differences, f of x minus g of x is 2x minus 3. So let's go to the next slide. You also can multiply and divide the function. So if you have a two function, f of x and g of x, and you multiply them together, then one of them in the one bracket here and another in the second bracket here, and you multiply them, you add a like term, you simplify it. Final answer is 3x squared plus 5x minus 2. Now this you already know how to do it, so it's not hard. It's just we mentioned for you to know that yes, for the function, we can add them or we can subtract them and multiply them and divide them. So here, let's say you have a f of x divided by g of x. Then the f of x you put on top and g of x at the bottom. And when you divide it, you get the answer 3, at which remainder minus 7 divided by x plus 2. So there's nothing new about this. However, let's go to the next slide and see what happened. The operations of functions are much more complex than these examples above. For examples, adding, subtracting, or multiply and dividing radical functions or rational functions, or find an inverse function. Moreover, you will learn to evaluate the combined functions such as f of g, f plus g of minus 5 equal how much. You will also learn to evaluate the composite functions and their domain restriction in this unit. So that's the introduction for you. Now, to demonstrate the complex operation of function, it is much easier to watch the instruction from the board. So I will go through with you to the next lesson on the board. So for example, here you see this is a notation f, we call it f of g of x. So this here, we get into the composite function. This is the composite function. The function g of x, we put inside the function f of x. So f of x is the outer function, and g of x is the inner function. And we wrote it in this way, is the notation of function. F of g of x, or you can write f and then bracket g of x like that. So either way, you can write either way. Then you get to be familiar with the notation of function. So for example, f of 2x minus 1 equal 5 of 2x minus 1 minus 4. So you will see which one here is the outer function and which one here is the inner function. So then you will find the combined, evaluate the combined, the composite function f of g of x of minus 2. Now, this is much easier when I explain on the board with you and we do the operation of the function. So this is just like for you to see how we operate. The operation of function can be like this. So let's go to the, you will understand about this better when I demonstrate it on the board for you. Okay, so I think very much this is what we learned today. And just one thing I forget to mention to you. One thing I forget to mention. I forget to show you, this is the picture of my little boy, my adorable boy here. Okay, so it's just for fun. Anyway, we went through the all of this. So let's go through quickly. So this is the slide. We will get into the next unit of our function and operation. So we will understand and identify what is a function and what is a one-to-one function. And we know how to use a vertical line test as well as horizontal line test to test whether or not it is a one-to-one function or it is a function or not. So the next we will learn the inverse function as well in this unit. We learn how to recognize the domain and the range of the function. And we know where is the domain, where is the range of each different function, of each different sketching. And we learn how to add them correctly, multiply them and divide them correctly. And we also learn about composite function and find the inverse function. So this is the new unit you will go through with me on the lesson. So now I get back to you. So I hope that you enjoy our presentation today. And each of the units, if I can make a PowerPoint presentation like this, you will see this more interesting and at least give you a general idea about what the unit look like and what the lesson we're going to learn. And then we get into details of each lesson. And so if you follow me from the YouTube, and you can watch the whole unit of my lesson plans in the course of Pre-Calculus Math 12. If not, you can visit my website, mymathteaching.ca, and you also can learn with me the whole course, set of course, by register online to my school, mathcourses-online.teachable.com, and you can practice, and you have access to on the sample solution and sketching and you know, like, so that you learn the subject more in a depthness and in more thoroughly. So thank you for watching my PowerPoint presentation today I share with you. Thank you for watching. I hope everyone have a good day, and bye for now. And see you, stay tuned for my next video about the operation of the function. There will be a lot more interesting than what we went through today. Bye for now.